So I thought I'd go ahead and mix things up a bit and remind us about Newton a bit and also how it relates to kinematics.
Perfect.
So in this example, we have a 10 kilogram box is at rest on a frictionless surface. At rest, it's probably going to come back to haunt us. It experiences acceleration, so we know this is the second law. We know that it accelerates. Okay. In case if I didn't make this memo earlier, the three kinematics equations, those are equations that we only use if acceleration is happening. So make sure you put that in your notes somewhere that we only use the kinematics equations, right? The three equations when acceleration is happening. So if acceleration is not happening, we don't use these equations. We go back to the easy stuff when we did motion diagram. A, calculate the acceleration of the box. Well, second law, and there's only one force. If I divide both sides by m, I get acceleration. So acceleration is the 50 newtons divided by the 10 kilograms,
You're welcome.
and I get 5 meters per second squared.
You're welcome.
So let's keep that in mind that it accelerated at 5 meters per second squared. All right, that's nice. If the box accelerates for 3 seconds, what was its final velocity? So, okay, accelerates from what? Well, let's do what like we're used to, right? Let's write the five things. We have v, v naught, a, delta x, and t. So we write 5, 3, 1. So we list the 5 things. Check. Now we identify 3 things they gave us. They gave us a time. We know the acceleration. We just got it up here. And we know it starts from rest. And we want to know what final velocity is. That means we listed the 3 things and we find out the one we're looking for. Write down all 5 variables, identify the 3 things they give you, and identify the one you're looking for. We don't need this variable, so I'm going to erase it. Which formula uses all 4 of these? Well, that looks like the first formula. And we're looking for v, so this is really convenient because it's already solved for v. This is a nice problem. It's already solved for v. So I'm going to just go ahead and plug in these numbers. Now, if it helps, I'm going to go ahead and put this over 1 because this second will cancel out with one of these seconds. And I have 5 times 3 is going to give me 15 meters over second. Now, let's keep track of some of these things. So far we know that we know that the velocity right now is 15 meters per second after 3 seconds of accelerating at this rate starting from rest. How far did the box displace during those 3 seconds? So, we had everything. We had v, we had v naught, we had acceleration, we had the time was 3 seconds. So actually, we have everything. We're looking for displacement. At this point, we have so much freedom that we could use either one of the 2 other equations to solve for this. I'm going to end up using the middle equation just because I know what I'm doing, right? You could have used the other equation as well, and it'll give you the same answer. I'm going to use this one because, one, I'm looking for displacement, and this is already solved for that. And 2, with this v not being 0, this term cancels out. So it's kind of convenient, kind of simple. So that ends up being 22.5 meters. And the beautiful thing here, for those of you following with the units, is that because this ends up being squared, right? This ends up being 9 seconds squared. These second squares cancel with these second squares, leaving you the meter. Okay. So remember, after 3 seconds of acceleration, it was going for 15. It was going at 15 meters per second. The box now moves with a constant velocity from part B for 10 seconds. If you're wondering, for those of you wondering, about what this looks like, here's your V, here's your T. Okay, and so if this is 15, it's going to be traveling like this, right, for 10 seconds. Now, once I draw this, you don't have to draw this, okay, but I'm just showing you the multiple representation of the same problem. You understand what to do. But let's say you don't know how to draw this. Well, recall that V is equal to displacement over time. And if I want to get the displacement, right, how far did it travel? I'm going to solve for delta x. I want to get this by itself. So multiply both sides by time. Yay. The t is 10 seconds. The velocity was 15 meters per second. Seconds cancel out, we're gonna leave with meters, and you get 150 meters. Now, of course, if you would have drawn a free body diagram, if you would have drawn a motion diagram, then you would have also recognized, hey, this is a rectangle, 10 times 15, 150. All right, the 50 Newton force stops pushing the box. So, it's been pushing it, right? It's been pushing it. And the box begins to experience a small friction with the surface that it's on. It takes about 15 meters to come to a complete stop. So now we have to go ahead and let's do this right. 5, 3, 1. So let's do the 5 things. There's V, V naught, A, delta X, and T. Well, it's been going at 15 meters per second, right? So that's your V naught. It takes a box this long to stop. And if it comes to a complete stop, that's 0. We want the deceleration. Okay, so what we've done is we wrote all 5 of the variables. We identified the 3 they gave us, and we just identified the one they want. I can erase this. I don't need this anymore. This is going to be modeled best by the third kinematic.
Most impressive.
We're looking for A. We've done this a few times already, but just to make sure, we will subtract this from both sides.
We want A by itself, so divide both sides by 2 delta X.
And we get, around that room, we get that acceleration is v squared minus v naught squared over 2 times delta x. Remember to keep track of these, right? Put them in the right order. Don't switch them around or you're going to get a wrong answer. This is deceleration, so it should be negative. It should be negative. Your answer should be negative. Not because you slap a negative on it at the end. It should be negative because you typed in the calculator and you got a negative at the end. I would challenge you to please try to put this in your calculator at one shot. Okay. What are some tricks you learned on this page? Talk about them, discuss them.